Alright, in this video I'm going to teach you how to integrate tangent x. But before you start to integrate tangent x, you will need to understand one of the integration formula, which is something like this. The integration formula is something like you integrate fx and then f prime x. Okay, it's dx, and then you will get the ln fx plus k or plus c, you can say, but the fx have to be modulus plus k. Okay, k is just the same as any constant value. Alright, basically this formula, if you know how to differentiate ln x, actually this formula is come from the how you differentiate ln x. Okay, let me just explain a little bit on this formula. Basically is okay, if you learn about how to differentiate ln x, I give you a simple example. If I differentiate the ln x squared, example, if I differentiate ln x squared, right? So what happened is, we know when we differentiate the ln whatever, we will get a 1 over this thing, isn't it? So x squared is at the denominator, and then what we need to do is we have to differentiate the x squared and write on the top right. Okay, so this is what happening right now. You just assume, if I call the x squared fx, so you can see the fx is at the bottom, and then this one is basically I differentiate fx, right? So it's f prime x. So this is what happens. So therefore, if I differentiate ln fx, so I'm actually getting fx at my denominator, and differentiate fx, which is f prime x, is on the top. Then what you do next is you add the integration sign for both. So integrate and d dx, you basically simplify, right? So therefore, if you integrate this thing, you are actually getting ln fx and then plus a constant. This is what we always do. Alright, so therefore this one explains how this formula come from. So okay, so right now we're going to use this formula to solve about how to integrate tangent x. Yeah, because in IGCSE syllabus, I always tell the student cannot integrate tangent x. Actually, you can if you go to the highest level. Okay, so what I will do first is I will change the tangent into the sine x over cos x. This is just a formula. So tangent x is actually equal to sine x over cos x. Okay, you assume the cos x, you assume the fx is a cos x, because the fx always at the denominator, right? So it's a cos x. So if I differentiate cos x, I should get negative sine x, isn't it? So therefore, this is what happened next is, in order to fulfill this formula, I want to make sure the bottom is the cos x, and the top here, numerator here, this one should be negative sine x. But I don't have negative sine x, so I only have positive sine x. So this is what I will do next is, I will multiply negative 1 for outside the integration sign and inside. I can always do this because actually it's like multiply negative 1 for both. If I multiply negative 1 for both, basically it's same idea with I multiply positive 1, which I doesn't change the value of it. Alright, make sure you cannot simply like multiply negative inside only. So you have to do like both the outside and inside, because negative times negative is changed back to positive, mean you doesn't change the value of this this expression, right? So okay, if after I multiply the negatives for sine x, right now I have the thing I want. So therefore, as long as this is fx, the top here is the differentiate of the fx, then you can straight away say this one is the negative ln fx, right? Your fx is cos x, right? So it'll be cos x plus k. Okay, this is what happened, and I always add the modulus for ln, because ln cannot be negative, so I always add the modulus for it. Alright, so yeah, this is how to do this kind of questions. So if you still do not understand about this formula, maybe in next video I will just explain more. Actually, it's quite simple. Maybe I just give you one more example before we move on to the next video. So example, okay, I just give you a random example. So what if I integrate something like 2x over 4 plus 2x squared, example. Alright, so if I want to integrate this one, okay, I know the denominator one is fx, right? So my fx is equals to 4 plus 2x squared. If I differentiate fx, I basically get 4x, isn't it? But the problem here is you don't have 4x. So if you have the 4x on the numerator, you can straight away apply this formula because the top actually is a differentiation of the bottom. So if you don't have the 4, what you can do here is you can multiply 2 by yourself, but you cannot change the value, right? Cannot simply multiply 2. You always remember the 1 concept. So what multiply 2, you get 1, which is half, right? So I didn't change the value because half times 2, I get back 1. And this equation can always multiply 1. I didn't change the value. Alright, this is a very important concept. Alright, so then I actually getting this is half integrate 4x over 4 plus 2x squared. So this one fulfill this condition, right? So bottom is fx, top is differentiation of fx. So this one I can say is half ln, and then I copy my fx, which is 4 plus 2x square plus c, or you can write plus k. Right, so yeah, actually it's not too bad about this formula. Yeah, you just need to use to it. You just always remember bottom is fx, top is a differentiation of fx version, and then when you have your equation it's possible to write in this pattern, then you can always use this formula. But sometime in the future you might see the equation is not possible to get the relationship between denominator and numerator, then you maybe need to use the integration by part or integration by substitution. Alright, so yeah, this is everything about this video. So I will talk to you guys in the next video. Thanks for watching.